this video, I'm going to be talking about how to solve game theory problems, which are typically applied in the context of economics anyway, to the oligopoly market structure. That is, the market structure that has a few firms. It could be two firms like Boeing and Airbus, the airplane manufacturers, or it could be more like the auto industry that might have, say, 5 to 10 big players. It could be the oil industry. You often hear about OPEC and the oil cartels and things like that, and that would all be considered oligopoly market structures. So game theory is a way of understanding how oligopoly firms make interdependent decisions. So for example, if Ford were to lower their prices on their trucks, Chevrolet might also be kind of by default forced to lower their prices too, because if everybody's buying Ford trucks because of the price is lower, then Chevrolet's going to have to lower their prices to compete. That's the sort of thing that you're kind of normally going to see with oligopoly problems. Now, we're only looking at two firms at a time. In this case, we're going to first start off with a non-economics example, and then we'll move on to some other examples that it might be more typical of what you would see on, say, the AP exam or an introductory microeconomics course at the college level. All right, so let's begin by talking about what game theory is. Game theory always involves at least two players, some rules or choices, different payoffs, and different strategies. So we're going to start off by looking at this scenario of Bonnie and Clyde. Now, what I typically do and recommend that people do is underline all of the payoffs that are going to apply to one player. And if you don't have color, what you might do instead of underlining, you might maybe put a box around one of the players, right? So if you don't have color, you could do it this way. So the player that's on the left is always going to correspond to the number that's on the left, and the player that's on the top is always going to correspond to the number that is on the right. So in this case, we have Bonnie and Clyde, notorious bank robbers. They've been arrested on charges of bank robbery. So let's suppose that they're being interrogated, and the prosecutor says, "Look, if we get you to if the other person rats you out, what we're going to do is give you 10 years. But if you confess, we're going to give you a better deal. But if you rat the other person out and they don't confess, we're going to give you even a better deal, but we're going to slam them with a bigger number." So in this case, if you look at Bonnie, if Bonnie confesses and Clyde confesses, they're both going to get 3 years. If they both deny it, maybe they can't actually hold them to bank robbery, so they might get them on a lesser charge of weapons charges or something like that. And so they might both get 2 years, right? But what would even be better than 2 years is 1 year. So let's just suppose that Bonnie denies, but Clyde confesses and rats out Bonnie. Clyde is now going to get a year. He's going to get a special plea bargain, and Bonnie's going to get 10 years. You could also do it in reverse, right? So you could say, all right, well, if Bonnie confesses and Clyde denies in hopes that Bonnie also denies, but then Bonnie ratted him out, he's going to get 10 years. They're going to stick that crime on him, and they're going to give her only a year and let her off, walk out the door. So this is kind of what game theory looks like. Now, what I'm going to be showing you is the check-a-box method, which is far easier than the more typical decision tree method. And I think the check-a-box method is a foolproof way of doing it. Works on the AP exam, and this is what I would recommend that people do. All right, so let's begin. So the first thing that I recommend that people do is to isolate one. Okay, so let's just assume that we think that Bonnie is going to confess. Clyde, what we're going to do now is we are going to try to figure out what is Clyde going to do given that he believes that Bonnie will confess? Well, if Clyde believes that Bonnie is going to confess, well, these are his choices, right? If he thinks that she's going to confess, he has a choice between either confessing and getting 3 years or denying and getting 10. Now, he would, of course, know in advance what the plea deals are that they're being offered, and assuming that they apply to them equally. So if Clyde is faced with these two decisions, Clyde is certainly going to choose to confess. And so what I'm going to do is I'm going to put a checkbox here for Clyde. So he's going to confess. And I'm also going to put a check here for confess because I want to remember later that he chose to confess at least that one time. So he's not going to want to deny, because if you're looking at the difference between these two decisions, obviously 3 years is far better than 10 years. So now what I want to do is say, all right, well, let's suppose that Bonnie, so put yourself in Clyde's shoes. If Bonnie decides to deny the bank robbery and Clyde decides to confess, and rat her out, he's only going to get 1 year. But if he decides to deny, he's going to get 2 years. So which is better? Oh, 1 year definitely is better than 2 years, right? And, so what you might expect is that Clyde is going to confess either way. And now this is what we actually call a dominant strategy, right? So what is a dominant strategy? So I'm going to just write the word yes here because we haven't dealt with Bonnie yet. But a dominant strategy is defined as where one player is better off regardless of what the other person does. So regardless of what Bonnie does, Clyde is actually better off confessing. Right? So you could also put it in this way. If you see two checks for confess, dominant strategy. And that's exactly what we see. Both checks for Clyde are going to be on confess. Okay. So we don't know about Bonnie yet, so now we're going to move on to Bonnie. So let's suppose that now you're Bonnie. Bonnie is looking, we're going to block off Clyde, we're going to look at one of his decisions at a time. Bonnie is looking at the choice between confessing and getting, we should start here. If we assume that, Bonnie assumes that Clyde is going to deny, she has a choice between confessing and denying. If she confesses, she's going to get 1 year. If she denies, she's going to get 2 years. So clearly for Bonnie, it's better to confess and get the 1 year. What I tend to do is I like to put the checks at the bottom for the person that's on the left-hand side, and the person that's on the top gets the check on the top above the number. It just helps me to mentally sort things better. Okay, now let's assume that Clyde confesses. If Clyde confesses, Bonnie has a choice between confessing and getting 3 years and denying and getting 10. Well, clearly, once again, Bonnie's going to be way better off by confessing. So in both cases, we're going to see that Bonnie is going to confess regardless of what Clyde does. And so answering this question, does Bonnie have a dominant strategy? Well, the answer is yes. And, well, why is that? Well, regardless of what Clyde does, Bonnie's going to be better off confessing. She's going to end up with, she can't control Clyde. She can only control her decision. So regardless of what Clyde does, this is the right decision for her. She definitely wants to confess, and so does Clyde. Now, the next question asks about Nash equilibrium. Now, Nash equilibrium basically means that when what one person does is optimal given what the other person does, it's impossible for either player to do better by unilaterally changing their own decision. It's basically the predicted outcome of the game. Okay, so you might consider a couple of the following: that each player is doing their best given what the other player is doing. The strategies reinforce each other. They're predictable and enforceable. What do I mean by that? It just means it's kind of like an unwritten law that no one would want to break because it's not going to benefit them, right? Why would either of these players try to do anything other than confess? I mean, that seems to be the best strategy for both of them. And here's the real kicker is that we know that it's Nash equilibrium because we see that there are two checks. And so what I'm going to do is I'm just going to write Nash right here. And so the answer is yes. And so the predicted outcome of this game is that they are both going to confess, and they're both going to end up with 3 years. We can predict that they're both going to confess and that they're both going to get 3 years based on understanding their payoffs and the fact that they both have a dominant strategy, and that in both cases, we would expect them to, why would you deviate from this? It's not going to benefit you. Now, somebody might look over here and say, hey, look, it's kind of obvious that they would actually be better off if they were to both work together, cooperate, collude, if you could, and deny, right? So that's true. But here's the problem. What if Bonnie and Clyde say, all right, going into this thing, we're both going to deny it no matter what. Well, and let's say that, say Bonnie, she's like, yeah, we're gonna deny it. And then Clyde decides to shift gears and they say, yeah, we're going to be here. And then he suddenly changes his mind and rats her out. Now Clyde gets 1 year and Bonnie gets 10. Does she want to risk that? Probably not. So they may love each other and all that, but so maybe people will stick together, right? Like in the mob, they'll take the time, but more often than not, they're going to do what's in their self-interest. So for this reason, what we call this, because this is actually a better outcome for both of them. So we would call this the prisoner's dilemma. And what it basically means is that if they were to cooperate, they'd both get 2 years rather than both getting 3. But if they were to choose to cooperate, they'd both have an incentive to break that cooperation and both confess. And so this is part of the reason that economists often say that cartels will break down over time rather than actually being able to hold to this better outcome for both individual players. So that's basically how prisoner's dilemma works. And it's easiest to understand it when you're looking at a situation like this, and then maybe go from there and move on to another example. So now what we can do is we're going to look at what you might expect to see in game theory, which is two firms. In this case, we're going to use two different countries. We're going to use Russia, and we're going to use Iran. And we'll do the same color pattern. So these are all of Iran's numbers. And again, if you don't have color, you can use a circle for one and a square for the other, or whatever it is that helps you to remember them. But I do think that this is useful so you don't forget who's who. All right, very similar. This time it says, suppose Iran and Russia are oil-producing nations operating in an oligopoly market, and each nation must decide to price its output high or low. See the payoff matrix that indicates their profits. All right, so maybe the easiest thing to do is to solve for Iran first, because it's asking about Iran first. So, and you could do it in either order. You could solve the whole thing and then go back, but I'll just go ahead and do one at a time. So let's start off by saying, all right, let's suppose that Russia, and I'm going to put my pen back here. Let's suppose that Iran believes that Russia is going to go high. What's Iran going to want to do? So if they price their output high, Iran can price their output high and make $20, or maybe it's in millions, but we'll just stick with $20. But if they price their output low, lower than Russia's anyway, then they might suddenly get a lot more customers and more profits. And so the goal here isn't less time, it's more money, right? And so we'd say, oh, Iran's going to definitely want to go ahead and price their output low. And so their first choice, given that Russia produces it sells at a high price, is for Iran. If they know that Russia's selling at a high price, they're going to want to price low, and they're going to end up with more profit. Now, if Russia priced their output low, then Iran would end up with, either $5 if they priced high, or if they price low, then they would end up with $10. Now, 10 is certainly preferable to 5. So in this case as well, Iran's going to want to price low. So we see that once again, we have 2 checks for low. So we know that Iran has a dominant strategy. So the answer here is yes. And I will just point out that there are 2 check boxes. So there's 2 check boxes at low, which means, and you could even say what it is, right? Their price low. What is that strategy? Price low, because they're going to be better off regardless, right? That doesn't mean they wouldn't prefer if Russia goes high and they go low, but they can't control Russia. They can only control Iran. Okay, so now let's go to Russia. Same story. So let's say that Russia believes that Iran's going to price high. They can price high or low. Well, if they price low, they're going to make $35 rather than 25. So that's better for Russia. If Russia believes that Iran's going to price low, if Russia prices high, they're going to get 10. If Russia prices low, then they're going to get 15. So once again, Russia is going to want to price low. In both cases, Russia wants to price low. So does Russia have a dominant strategy? Yes. You want to price low. Regardless. It doesn't matter what Iran does. You're going to want to definitely price low. Is there a Nash equilibrium? Absolutely. That Nash equilibrium is where you find the 2 checks. Okay, so that is your Nash equilibrium. So yes. And you could say both go low, low, low. Is this a case of the prisoner's dilemma? Now that might seem like a strange question because these are obviously not prisoners, right? Now the prisoner's dilemma doesn't actually mean that anybody's a prisoner. All that it means is that one of the players, well, let me rephrase, that each player is going to have a strategy, whether it's confess or not confess. But when both players play their strategy, their combined payoffs are going to be smaller than if they had both played their other strategy, right? So in this case, you have Iran and Russia. They both have a dominant strategy of going low. But if they would have played their dominated strategy or their dependent strategy, depending on how you want to phrase it, they would have both collectively been better off, right? So the answer here is yes, they do have a prisoner's dilemma situation, meaning if they would have both priced their output high, instead of making 15 and 10, they would have made 25 and 20. So that's an extra $10 each. So the answer here is yes. If they would have both played their dominated strategy, which is high, they would have been better off, right? Now, I'm not really explaining that in a lot of detail, but that's basically what it is. So you could write that here too, that this is your prisoner's dilemma. Okay. By the way, so the predicted outcome here is that they're both going to price their output low, and this is the amount of money that they're going to make. Now, so this starts to get into the interesting thing about game theory. There's often a lot of discussion about cartels and OPEC, but see, the issue is that there's an incentive for firms to cheat, right? Let's say that Iran and Russia colluded and said, all right, yeah, let's both raise our prices really high, so we'll make lots of money together. they will both have an incentive to cheat and to lower their prices. And when they do, let's say they both do, or one of them does, the other one's going to get screwed, right? And so cartels do tend to break down over time unless there's some sort of an enforcement agent, whether that's the government, or maybe it's like Iraq invaded Kuwait in the 1990s. That's one way of enforcing it. All right, so let's go to the other side. All right, this time we've got two different companies. We've got, this time we're going to have Google and we're going to have Apple that both produce smartphones. And in this case, let's look at their payoffs. We're talking about advertising and not advertising. So again, Google is the left side, so they're always going to be the left number. So suppose Google Android and Apple iOS, the iPhone software or smartphone software, are smartphone producing firms operating in an oligopoly market, and each must decide whether or not they will advertise on television. See the potential payoffs shown in the payoff matrix. Okay, so let's start off by just solving for one of them. Okay, so we can, maybe this time we'll start off with Google. Let's suppose Google believes that Apple is going to advertise. What is Google going to want to do? Well, clearly they're going to make more money if they advertise than if they don't advertise. So it looks like Google is going to want to choose to advertise, because 250 is a heck of a lot more than 100. Suppose that Google believes that Apple is going to or is not going to advertise. So under this column we see that for Google they're going to make $300 if they advertise, but if they don't advertise they're going to make $350. So that's better. Okay, so notice that you've got a check for each one. So Google does not have a dominant strategy. They have what they call a dependent strategy, meaning it's going to depend on what Apple does. So let's go to Apple. If Apple believes that Google is going to advertise, what is Apple going to want to do? Well, not advertising is going to be only $75, but advertising is going to earn them $200. So they're obviously going to want to advertise. If Apple believes that Google is not going to advertise, Apple would make $500 by advertising and only $400 by not advertising. So clearly $500 is better than $400. So in this case, we see that Apple does have a dominant strategy, right? They're going to advertise regardless, but Google does not. All right, so let's also notice, though, well, we'll get to that in a minute. So I'm just going to jot this down. So we'll say that Apple yes, and that strategy is to advertise. But for Google, the answer is no. They have a dependent strategy. Okay, and that means that it depends. Now, what will Google actually do? Well, we see that there's two check boxes here, so this gets to the Nash equilibrium. The answer here is yes, there is a Nash equilibrium. And where is it? Well, it's where you see the two check boxes. Your Nash is here. You see two checks here. That means that your Nash equilibrium is going to be for Google to advertise and Apple to advertise. How much money will each firm make? Well, you can see by looking at this number that Google is going to earn $250 and Apple is going to earn $200. So we could just jot that down. So Google, notice how much less Apple's going to make by Google choosing to advertise. So Google is going to equal 250, and Apple is going to be 200. We'll just go ahead and underline them to keep with our color coding. Okay. So in this case, you have a Nash equilibrium, but you do not have two dominant strategies. You have Apple with a dominant strategy, but Google with a dependent strategy. Okay, the last one that we want to do is Boeing and Airbus. And this is going to be a slightly more complicated question, and these sometimes do occur on the AP exam. Whether or not your professor or your instructor gives you these types of questions is a different matter, but we'll do this in two parts. So this time we've got Boeing and Airbus. It says Boeing and Airbus are two firms that commercial aircraft producers who must decide whether to produce large or small airplanes. The potential payoffs for each firm are shown in the payoff matrix. So here's Airbus. We're gonna actually, let's do Airbus in blue again. These are all for Airbus. And for Boeing, stick with red for Boeing. Okay. So let's start off by solving for Airbus. So if we assume that Boeing is going to produce large planes, what's Airbus going to want to do? Well, clearly, by producing small airplanes, they're going to make more money than if they produce large airplanes. So assuming that Boeing's making large airplanes, and this is the payoff that pertains to Apple, or I'm sorry, to Airbus, they're going to want to produce small airplanes. So we're going to have one checkbox there. And the next one, if Boeing decided to produce small airplanes, Airbus would make $90 by producing large airplanes, and they would make $100 by producing small airplanes. So once again, small airplanes is going to be better for Airbus. So we can see right away that Airbus has a dominant strategy. So I'll just write that over here. Airbus, yes. And that strategy is small airplanes. Okay, now let's solve for Boeing. If Boeing believed that Airbus was going to produce large airplanes, Boeing would want to produce small, because the small airplanes are going to earn $100 rather than large airplanes, which is only $90. So we're going to go ahead and put a check here for Boeing. So one check for small. If Boeing believed that Airbus was going to produce small airplanes, then Boeing would have to choose between large and small, and large airplanes seem to earn them more money at $100 rather than small airplanes, which would only be $80. So we'll put a check here for large. So we got one check for each for Boeing. So Boeing they are going to have a dependent strategy. Okay, so the answer directly is no. They have a dependent strategy. That is that they're gonna if Airbus produces small, then they're going large, and if Airbus produces large, then they're going small. Okay. Next question. Is there a Nash equilibrium? Well, you can probably tell right away. Yes, there is. There are two checks in this box, and that is your Nash equilibrium. So the predicted outcome of this game is that Airbus is going to produce small and Boeing will produce large. Now this is the complicated part. Suppose that the government gave a $20 subsidy to the producers of large aircraft only. Redraw the matrix or the payoff matrix to reflect the subsidy policy in the space below. So what are we going to do here? Well, this is a little bit more complicated than some of the other problems. So what we'll do here is we're going to actually add $20 to all of these numbers that pertain to large airplanes, but large only, okay? So that's plus 20 here, plus 20 here. That's small, so that's not going to count, but this one will, right? Because that pertains to large airplanes. These are both small, and this is a, this is for large airplanes. So we would add $20 here, but not here, okay? So we're not going to add anything to small airplane production. So your new numbers, if we add 20 to these numbers, we're going to have 110 and 80. You're going to have 120, because we're adding 20 to 100, and 120. We're going to have 100 still here, but we're going to add 20 to that 90, so we're at 110. And these numbers are going to stay the same. Okay, now we can do the same as we did before with Boeing being red, and we can resolve this problem based on the new numbers. Okay, and this was an AP exam question one year, so it's worth knowing how to do this. Not this exact one, but it was similar. All right, how does the following change? Well, we don't know yet. We got to solve it. So let's go ahead and solve it. So we'll start off once again with Airbus. So let's assume that Boeing. Well, I'm sorry. We'll solve it for Airbus first. We got to do it this way. So let's assume that Boeing goes with large planes. What's Airbus going to want to do? They're still going to want to produce small. Let's suppose that Boeing chose small planes. Oh, look what happened. Now Airbus is going to want to go with large. So Airbus no longer has a dominant strategy. They have a dependent strategy. So Airbus they now have a dependent strategy rather than a dominant strategy. Now let's solve for Boeing. So if Boeing believes that Airbus is going to make large airplanes, Boeing is going to have to choose between large and small. And it seems that large, 120 rather than 100, is a much better deal for them. So we would expect them to choose large airplanes. Now let's suppose that we're assuming that Airbus is going to produce small airplanes. Boeing's going to have to choose again. 120 for the large airplanes, or small airplanes you get 80. Well, obviously 120 is a much better deal. So they're going to again choose to produce large airplanes. So now Boeing has a dominant strategy. Okay, so they flipped, right? However, this is kind of interesting. What about the Nash equilibrium? Well, interestingly, the Nash equilibrium is the same. It's here. What they produce is not going to change because we still see the two checks in the Airbus small, Boeing large box. So the Nash equilibrium is the same in the sense that it's the same production. However, what will change is that now Airbus will earn 120, which is what they earned before. That's actually the same for them. But Boeing, I'll switch colors here. Boeing is going to earn, instead of earning the $100 that they earned before, Boeing is now going to earn 120, which is an additional $20. Just underline that because that's for Airbus. So that's how you solve game theory problems. Obviously, they can get more complicated than this. And there are game theory problems out there that are much more complicated. But for the purposes of, let's say the college introductory microeconomics courses or the AP micro exam, you're not going to see anything that's much more complicated than this. A couple of other things to remember. You're not going to see a AP exam question where there's two Nash equilibriums, because it is actually possible, but you won't see it. So for the purposes of the AP exam, this worksheet is more than adequate to get you to understand game theory is about as complicated as it's going to be on the AP exam or in a basic college course. There is an alternate method of using the decision tree methodology, and that's normally what most textbooks teach. But I would just stress that the check-a-box method is so much easier. All that you have to do is isolate and block things off with whether it's your finger or your pen. And that concludes this discussion on game theory.